This video is on topic 2.3, the structure of ionic solids. And today we're going to talk about particulate representations for ionic solids. I'm Alice Pooty, and I'm happy to be back with you on AP Daily. And so an ionic bond then, as we mentioned in the last video, is the electrostatic attraction between cations and anions. And so remember that electrostatic just means the attraction between positive charges and negative charges. And so there are several different ways that we can represent that. And you can see two pictures that are here. So the picture on the left shows our particles that are packed very closely together and alternating positive and negative charges. And you can see that the negative charge is larger than the positive charge, so that's all represented. The other thing I want you to notice is that this isn't one individual molecule. So in other words, there's not just one positive charge and one negative charge that are bonded together, that you can see that there's a repeating structure over and over for this solid crystal. The picture on the right shows a similar drawing, except there's a little more spacing, so you can see the spatial arrangement of the particles. And this one is for sodium chloride, but you can still also see that the chloride ion is larger than the sodium ion. Ionic compounds can conduct electricity, but not under all conditions. So in order for anything to conduct electricity, it has to have charged particles, and those particles have to be free to move. And so if we start with the solid structure, we do have charged particles that are here, but what we don't have is the freedom to, the particles don't have the freedom to move. And so because they are trapped in this crystal lattice, they can't move around, and so this is not going to be able to conduct electricity. If we look at a melted or molten ionic solid, now we still have those same charged particles, but the particles can now move around freely, and so this should conduct electricity. In a later unit, you'll also talk about what happens when ionic compounds dissolve in water and why those are also able to conduct electricity. If we take a look at the structure here, we have a picture of lithium chloride where the lithium are the dark circles and the larger gray circles are the chloride ion. And a student wants to draw a structure for potassium chloride. And so the question asks you to describe how the student should change this drawing to represent potassium chloride, assuming that lithium and potassium chloride have the same structure. So the big thing you want to recognize here is that lithium chloride, or the lithium in lithium chloride, is going to be smaller than the potassium ion. And so when you draw it, you would want to draw your potassium ion so that it's going to be a larger circle than the black circle that's given here. So potassium's ion then is 138 picometers, lithium's is 76, and you certainly do not need to know these numbers or try to memorize them, but this is just to show you kind of the difference in size between the two ions that we have. And so you, as I mentioned, you're going to want to draw a larger circle to represent the potassium ion. However, notice that the potassium ion is smaller than the chloride ion, so it still needs to be smaller than the gray ion. One thing also just to point out here that the question does say to describe. So in other words, you don't want to just draw the picture, you also need to use words in your description as well. So what I'd like you to do now is to read this question, take a look at the diagram, and then explain the error in the student's particulate diagram. Press stop, answer the question, and then press play when you're ready to check your answer. So there are two errors in the student's drawing. The first one is that the lithium should actually be the smaller ion and the bromide should be the larger ion. The other one is that the student has drawn the lithium ion as being all together in a row, and since these are all positively charged, they would actually repel each other as with the bromide ions. So a better way to represent this drawing is to, first of all, make it so that the bromides are the larger ion and the lithium is the smaller ion, and then to alternate ions so that we have these particles being attracted to each other instead of repelling each other. This is the end of the video. Thank you for watching. The next video is on metal structure and alloys. This is Mrs. Pooty. Have a great day. This video